Hi everyone. Good morning. So, yeah. Hi, I am Sivasubramanian, Comcast assignee for LIG. So this session we are going to talk about what is RDK, how to port RDK, how we port on 96 boards, and the challenges we faced. So what is RDK? So RDK is a complete set of software components, tools, and documentation required in process of making standard Linux set-top boxes. So RDK uses Yocto build system. So it's modular, configurable to meet the requirements of different set-top boxes like QAM based or IP based or hybrid set-top boxes, and the different configurations, gateway or media server or client configuration. So like any other set-top box software, it supports main set-top box functionalities like live playback, live streaming, DVR, and TSP playbacks. So RDK also supports web content displaying, graphic content rendering using WP browser. So this we'll see in detail in coming slides. So architecture, we use windowing framework as well, and previously we used Qt WebKit, and now we moved to Wayland. So if Wayland comes into picture, then comes a question: what is a compositor? So we use Vesta's compositor, which is RDK developed and open sourced. It's a like alternative to Western. So browser framework, we use WP, which is a metrological WebKit port with Wayland support. Graphic engine, so RDK uses OpenGL and ES, which has support for means hardware, which can use the hardware acceleration support also. So the main part, media framework, RDK defines its own media framework, that is RMF RDK media framework, which is based on GStreamer, which we'll see in detail in coming slides. And so startup services and that process management is done by systemd services. Okay, this is the architectural diagram, and you can see how RDK is layered. We have like 4 layers. Top one is that application where you'll have STB, standard applications guide, all those things. And the next part is that core RDK, generic RDK, which has that RMF framework, browser framework, all that need for video, web graphics rendering. And we have SOC and OE specific changes. Say we have a hardware acceleration on a board that comes in comes in the SOC layer, and OEM specific changes will come in OEM layer. So this media framework, browser framework, and the Vesta's we'll see in the coming slides one by one. So this is how to port RDK onto on any platform. So these are the major blocks identified, like media playback using hardware acceleration. And next is Vesta's compositor. So how Vesta's compositor can be ported on platform using the EGL or GLES support from the hardware. And then comes a browser, means we use a WP browser for displaying a web page or graphics content on the RDK. So these are the 3 blocks which we are going to see in detail one by one in coming slide. Okay, so RMF, what is RMF? RMF, as I said, it's a media framework which is loosely based on GStreamer with a level of abstraction to define RDK sources, sinks, and filters, which were required for implementing STP functionalities. So we have like different sources like DVR, QAM, home networking source, DVR sync, and sinks like DVR sync, home networking sync, and media player sync. Different things, but I will take one use case like how IP streaming playback is done. So that this is a diagram. So the left hand side shows how gateway streams. So we have QAM source and HN source. So QAM source will give the impact TS content, and HN home networking source will stream the content. So this on the gateway side, and the right hand side is on the media client box. So since our board doesn't have tuners, we'll see how media client functionality can be ported on our boards. So, RMF, this RMF sources and sinks internally translate into GStreamer pipeline. So, like in our use case, HN source uses SOUP HTTP internally, and media player sync uses player bin sync plugin. Player bin sync plugin is a bin of element which will have dmax, decode, and displaying display syncs. So how we integrate means how we port RMF onto a platform. So if our platform has a hardware acceleration, we need to integrate RMF through SOC or SOC specific plugins. So on high-key we don't had a hardware acceleration on, but DB board we had hardware acceleration through V4L2 plugins. So that we'll see on the high-key or means DB board specific slide. Okay, so here comes Westeros. So what is Westeros? Westeros is a simple VLAN compositor like Western. So this is a simple, lightweight, and developed by means Comcast, and they open source it. And mainly this is developed targeting the embedded systems. So it supports similar functionalities like normal compositing, nested compositing, and embedded compositing like Western. So how we port Westeros on a different platform? So we need to implement a Westeros SOC, which provides Westeros GL and Westeros video sync. So Westeros GL is for graphics, content rendering, and Westeros sync is a plugin for video rendering. So we implemented Westeros GL on high-key and DB for 10C using DRM KMS support. So how Westeros flow is like, Westeros will try to use EGL support. If native window support is not provided by your EGL support, we need to implement that Westeros GL using means on our case, Hikey and DB4 we don't have a on-screen EGL support, so we implemented the native window support using DRM KMS. So that we'll see in the Hikey slide. So we have a simple sample application to validate Westeros compositor, the Westeros test application, and these are some of the code links. So as I told, it's open source component, so it's available in GitHub, and you can do contributions through code.rdkcentral.com. So WP is a metrological port of standard WebKit with VLAN support. So WP is used for rendering web page graphics content or video content on web pages. So WP can be ported using VLAN EGL support from the board for graphics rendering, and GStreamer plugins for video content rendering on the web page. These are the boards we already ported. We already ported RDK on Hikey, Dragon board 410C, and on 820C we are in process of porting RDK. So this is how we ported on Hikey. So as I said, we don't have a tuner on the Hikey board. We ported a media client build on Hikey. So we used Yocto 2.1 means Krograd branch, and so Meta RDK is a distro by itself, so we don't need a means external distro. So we used it as a distro on 2.1. Okay, so the graphics integration is done by integrating ARM Mali 450 userland libraries, and we don't have a hardware video acceleration, so we used a software playback, video playback on the Hikey. These are some of the issues and challenges we faced on Hikey. So migration issue is like Meta RDK is DAISY based distro, but we ported on 2.1 Krograd branch, so we had migration issues with some of the components like GStreamer, LightHDBD, and WP dependencies. Yeah, so Westeros previously doesn't have a support for DRM KMS, so porting on Hikey was not that straightforward. We had to implement DRM KMS support using GBM, so that we implemented, since it doesn't work straight away by integrating the EGL libraries. Yeah, on the browser side, we have like video positioning issues. We used GL image sync on the WebKit media player. So positioning was an issue, since GL image sync doesn't have positioning. So that we solved using Westeros Sync. Yeah, so performance issue was there with media playback since we use software video playback, and as we don't have a hardware acceleration on high key. So this is with porting on DB410C. So some of the steps are similar, and with respect to specific DB410C related stuff. So GLES libraries, that graphic support here is provided by MISA FreeEndo driver. So we had like some of the challenges which we'll see in next slide. And so here we did RMF integration with hardware video acceleration through GStreamer V4L2's plugin. Yeah, here is some of the challenges we faced on DB410C. In addition to the whatever we did on high key, we had V4L2 compatibility issues since we use for Linaro 4.4 kernel, and RDK uses GStreamer 1.4.4 version. So upstream V4L2 plugin was not working, but we had to use a custom old V4L2. Yeah, so WP had a porting issue, like since Westeros doesn't provide a off-screen EGL target for MISA, the fallback mechanism which WP had, that P buffer, pixel buffer, that is also not supported in MISA. So we had to implement off-screen EGL target for Westeros, only for MISA backend. So the video positioning issue is same like high key. We had like playback issue. So WebKit media player has different pipeline, audio, video, and text pipeline. So the text pipeline and the native video pipeline was stalling the AV playback, so we had to disable that. So which is one of the issues we faced. Yeah. Any questions?
Thank you. And what is the generic license for the whole package?
RDK generic license. The generic RDK, they are licensing using RDK license. RDKM.
So it's like FreeBSD.
It's like community.
Comcast is generally taking certain portions and open sourcing them. So it's a steady march. Their goal is to have RDK completely open source with an Apache 2 license, I believe, is what they're targeting. So they're like on the RDK, the broadband gateway, the networking code has all been upstreamed. The WebKit for Wayland is an open source project. Again, it's coming in pieces. So it's a large corporation that is moving in that direction. But like I said, there is a license agreement with RDK. There's a lot of people who use it, and they don't actually deploy any products, but they use it as a reference, or they maybe compare their own products against RDK. But there's, as we say, a steady march towards getting the entire code base, open sourced from Comcast perspective.
What's remaining to be open sourced?
Can't, off the top of my head, I'd have to go back and look at currently what's there. Yeah, do you know?
They have plans to open source that generic RDK, but we don't know how far it's.
Just don't know right now. I'd have to look.
The changes that you made in Westeros to support the Freedrino driver, have we tried to sort of upstream those back to GitHub, their sort of GitHub project?
Yeah, we upstream to meteorological WebKit for Wayland.
Okay. And my other question was, is there any, does RDK come with any kind of middleware sort of GUI stuff when you have it all running?
User interface?
Yeah.
RDK doesn't means that MSO part is CPC component, means Comcast proprietary, so that they are not giving means under RDK license.
Okay.
So MSO can develop their own user interface.
The way it's segmented is you have the RDK media framework, and then you have what they call proprietary components. So theoretically, somebody can deploy RDK and put their, Comcast has their XRE guide, for example. Some other operator can deploy RDK and then put their own guide on top of it. So the guide interface.
It's kind of like the base components needed,
Yes,
essentially,
right.
yeah. But once you ported it, you don't get this nice sort of shiny
But does
UI.
the RMF, is there not just some sort of basic,
We have a sample applications to validate RMF.
Yeah, okay.
Yeah, so for graphics browser also we have a RDK browser, means which is available under that RDK license.
Okay.
Actually, I don't know that question is the right question to ask. So I think, for browser engine, so I think most people like the Blink, the Chromium Blink. So I just don't know why RDK still keep use WebKit. Is there any special reason for that?
Means can you come again? Can you come again?
Okay. Okay. I just say, for the RDK, it still use the WebKit as the web engine, right? But lots of open source projects just move into the Blink, Chromium Blink. I just don't know, is there any special reason for RDK to keep use the WebKit?
I don't have a straightforward answer. They have validated Chromium Blink also, but they found this is better.
I mean, the performance-wise, as well as when you Blink implementation, the stack size is more, and the performance is also not that much what they expected. So they stick to the meteorological WebKit. Yeah.
So, but I think Mark has something to say. Yes.
Yeah, so in LHG, we were proposing Chromium Blink. And that was Comcast's plan of record to go to Blink. However, a couple things happened. One is they decided to backport to older set-top boxes that were more memory constrained. And as Kalyan mentioned, they were disappointed by the code footprint size. And as some of you may know, Kazim was working on that Chromium browser project, and part of that I think we'll still try to resurrect, which is to really get the code size. So it was really, the performance wasn't quite what they thought, and then also the main issue was the code footprint.
Any other question? Okay, thank you for attending.